Hi there, this video is about decision making, and this is going to use Boolean operators to make decisions if we want to do something or not do something. We'll follow some specific code in the examples. And the code examples talk about different kinds of operators, relational and logical. So in addition to the mathematical operators and the assignment operator that we have had, we're going to talk about some new operators. At the end of this video, you should be able to follow some code and follow the output with an if statement. Know the difference between that and an if-else statement. And then if you have a whole bunch of decisions to make, we try to be efficient and use switch statements. Like this page says, relational operators compare one value to another value. It's very similar to your math class, but you don't write greater than or equals like this right next to each other. You have a different symbol, right? You would use this in math, which is the same thing. Starting from the second from the top, these are very similar to math. Strictly greater than or equals, less than or equal. This is not done in math. It is not equal to, which is kind of the opposite from this one up at the top. We talked about in class that if we're going to put two equal signs together, it's going to be a question. Are they equal to each other? You don't really ask if something is greater than or less than in math, but in computer science, you're going to use that to make a decision. We have this Boolean data type, and we know that a Boolean data type can contain true or contain false. And let's look at some Boolean expressions. We are asking Boolean questions, which would result in a true or false. We could compare two characters, the character A and the character B, and it is true that A is less than B, because remember that using the ASCII chart, a letter A is represented by 65, and a letter B, if you look at your ASCII chart, is 66. 65 is less than 66, so it is true that A is less than B. Lowercase d, however, is not less than lowercase a because they are represented by the ASCII values 197. Here's a third example, lowercase t less than uppercase x. We are asking the question, and the question is 116 less than 88? And obviously it is not. Here's some logic, and we have more operators. Here's what we call the AND operator. Two lines like this are the OR operator, and this is the NOT operator. It negates it, just like a negative sign in math. These symbols right here are on your keyboard. You probably have hardly ever used them. They are associated with the backslash. So if you looked above maybe your Enter key or looked for your backslash key, if you go Shift and then backslash, you would get an uppercase line. So for truth tables, and OR are binary operators. That means, remember, that they take two operands. You need to have an expression on the left and an expression on the right, and then you evaluate it. So this table shows that if you have true on one side and true on the other side, it evaluates to true. But everything else evaluates to false. Another way of saying that is if at least one is false of the two operands, then the evaluation is false. For the OR operator, it is a little bit different. If both operands are true, the result is true. But also, if at least one of them is true, the result is true. You can have a true and a false, and it's true. This one can be true, and this one false, true. So they both have to be false for the operation to be determined false. NOT is a unary operator, which means it only has one operand, and basically it makes something true false and something false true. It is the opposite in logic of what it used to be. As far as what's the most important, here is an abbreviated chart, but we're building on our precedence table. We have our NOT operators, our unary operators in general, our plus plus and our minus minus, which are unary operators, and those are the highest priority. Those would take place first. You go down to multiplication and divisions. Here's addition and subtraction. Keep on going. You are comparing. Are they greater than or less than or equal to, etc.? This is below this and is higher priority than or. And then assignment. Once again, dead last. An example of how you might work this is posed in this particular question. You ask yourself, is 5 less than or equal to 5? And that is true, and this is inside the parentheses, and so we do that first. We AND that with the result of this, 6 greater than 8. That's false. So I'm just going to stay on the left side for now. True and false evaluates to false because AND implies that they both have to be true, and we could look at that truth table. We finally get over to this right-hand side. 5 not equal to 6. Well, 5 is not equal to 6, so that's true. And so this just comes down. False or true evaluates to true. What I want you to do now is I want you to pause the movie and work out this one. And then I will show it worked out. Okay, you've started up the movie again. This is how I would expect a show of work. 2 greater than 3, so that is false. False or 5 greater than 4, that's true. So false or true is equal to true because one of them is true. We're going to AND that. This is how I make AND signs. We're going to AND that with not 3 less than or equal to 5. So 3 less than or equal to 5 is true, but we are negating that, not true. Not true is false. So we are ANDing true with false. True and false is false. Now we get to some code to use these logical operators, and we talk about the if statements. We have a declaration, int num is assigned to, and we ask if num's less than 10. So the syntax for if statements, if is a reserved word, these parentheses must be there, and inside here we have a Boolean expression, a Boolean question. Is it true? Is it false? Well, num has a value of 2. 2 is less than 10, so this is true. If it is true, we go into the body of the if statement, which is what we call this particular statement. Therefore, what gets output is I have a low number. And an if statement is only associated with one code statement. We'll modify that slightly in just a little bit. Down here, this says system.out.println, what is your number? So I have a low number, prints to the monitor because this is true. What is your number also prints because it is the next line of code that happens. Now let's look at this. Let's have some poor indenting and see what happens. We have the same code. Int num is assigned to. If num is less than 10, 2 is less than 10, so the Boolean expression is true. So the SOP right here, I have a low number, prints out. But so does this. Just because this is indented doesn't mean that it goes with the if statement. It applies to the immediately following single line of code. If you would like both of these to happen no matter what, then you could surround them with curly braces, like this. This open-close curly brace pairing makes this all happen with the if statement. It's all associated with that. So if you want multiple actions to happen, if the Boolean expression is true, then you encase them in curly braces. Here's a nice flow diagram of what happens with the if code. You make a Boolean test. You test something if it's true or false. Here is your Boolean expression. If it's true, whatever code that you put inside the body of the if statement happens, and then it flows to the rest of the code. If it's false, it just flows to the rest of the code and never visits the body of the if statement. There's another kind of structure. Maybe you want one thing to happen if it's true, a different thing to happen if it's false. So the if-else pairing works like this. Here's your Boolean question. If something's true, you have a statement 1 or several statements. The body of this part of the if-else structure occurs and then flows down to the rest of the program. Else, it's false, and this body occurs, then goes down to the rest of the statements following. For instance, num is now assigned 12. 12 less than 10, that's false. Therefore, this does not occur. The else part of the statement does occur. The body of the else statement says system.out.println, what is your number? It would only print out one thing or the other. Something very important is this is really only one line of code, because only this or this would happen. They can't both happen. Two important things to realize is you do not have another test right here. Okay, so you would not put that, your program would not run. That would be a syntax error. And there is no semicolon here. When I was first coding, I would put a semicolon here, and then my if statement would never work right. You can nest these, put one inside another. We have a pairing of if-else statements on the outside, and we have a pairing of if-else statements on the inside. We have nested this inside the outer if-else pairing. It is true that the else always pairs with the immediately prior if. So you kind of have to go from inside out. This else pairs with this if, therefore this else must pair with this if. So here's what happens. If num is greater than 0, and we don't have a value for num in this particular case, but here's a really good use of modular. If num mod 2 is equal to 1, remember that's what we say, is equal to it. If we have two equals, you could say equals equals, but you can also correctly say equals. Another way to think of num mod 2, and you're questioning if num mod 2 is equal to 1, you are asking right here, is my number odd? And that's a fantastic way to use modulo, especially, well, I guess mod 2. If it's greater than 0 and it's odd, then your number will be positive and odd. Else, if it's greater than 0 but it's not odd, it must be even. Remember, no Boolean test here. SOP, your number is positive and even. This comes into place if this Boolean expression was false. If it wasn't greater than 0, your number would be negative, or 0. You can have nested if-else statements, but you can also have consecutive if-else statements. So let's look at this. If answer is greater than 5, if that's true, answer is incremented by 1. Else, so if it's not greater than 5, else, if answer is less than 4, answer minus minus, it's decremented by 1. Else, there's another option, if answer is equal to 5, you add 30 to it. Else, if none of those are true, you print out I'm done. Now something about else if statements. the first time that a statement evaluates to true, any of the Boolean questions, it kicks out and it goes to the bottom. It's done. So for instance, if this were true, it would be incremented, and then it would go all the way down here to the next line of code. So I want you to pause this again, and on a scratch piece of paper, I want you to pretend first that the value of answer is 10, and tell me what would happen. Then I want you to pretend it's 6, tell me what the output would be, 5, and then 4. So 4 separate little mini problems. So pause the video right now. So here I'll work them out now. So if answer is 10, okay, so this is, I'll name this 1, 2, 3, and 4. So I'll work out one up here. Okay, the value of answer is 10. And answer greater than 5, is 10 greater than 5? That's true. Answer plus plus, answer is now 11. And we are done with the if-else chain, and we say goodbye. So the concluding value of answer is 11, and printed out is goodbye. Okay, so number 2. Answer is 6. 6 is greater than 5. Answer plus plus. Okay, well, so this is kind of boring because exactly the same thing happens. Okay, the value of answer is incremented to 7, and it prints out goodbye. Because no matter what happens in this chain of if-else statements, this is the next statement that occurs. So all 4 of your answers should say goodbye. Okay, let's look at number 3. Number 3, here's the value of answer. It is 5. Can't read that. Answer strictly greater than 5, false. Else answer less than 4, false. This does not occur. Else if answer equals 5, true. This is the first true Boolean statement. Answer plus equals 30. So 30 is added to 5. So answer now has a value of 35. And goodbye. Prints, because it goes from here, kicks out, and goes to the last statement. Let's do the last one down here. Number 4, the value of answer is 4. 4 greater than 5, false. This does not occur. 4 strictly less than 4, false. This does not occur. 4 equal to 5, false. This does not occur. This is the last one. Else, I'm done. So I'm done prints out. Also, goodbye prints out, because that's the next line of code. The final value of answer never changed. It is still 4. You can have multiple Boolean tests inside the same if statement. But what you can't do is you can't do it like math. But here you have to say 2 statements. These are ANDed together. Num is greater than or equal to 5. Is that true? And num is less than 20. So here is the outside of the if parentheses. So whatever this whole compound Boolean statement evaluates to depends on whether this body is implemented or not. This code up at the top would be the same as this code down at the bottom. If num is greater than or equal to 5, well, if that's true, this happens. If num is less than 20, well, if that's true, this happens. Okay, the same thing would have happened up there. There's no real preference. Maybe one is more readable to somebody than another. Notice that this if statement has one statement, which happens to be an if statement, okay, and this if statement has one statement in its body, and that's a system.out.println. There's something called short-circuiting in the Java language, and this is how short-circuiting works. We have a compound statement. We have 2 things we are ANDing together. Java knows that both of these must be true in order for the result to be true. So short-circuiting says this: if this first test of the Boolean statement is false, there's no reason to test this, because it doesn't even matter if this is true or false. It's going to be evaluated to false. So this would never be visited. And in this simple example, it's not really a big deal, but we'll get more complicated ones where it will be important to know if this is visited or not. Similarly, we have a compound statement down here that is ORed together. Java knows that for an OR statement, both of these have to be false in order for it to be false. So if num greater than or equal to 5 was true, once again, this would not be checked, because if one of them is true, it doesn't matter. The whole expression is true. So what I wrote, if a num had a value of 7, the compiler would again short circuit. It knows that it only needs to check 1. And our last topic is that of switch statements. So you see the general expression of a switch statement from the top to the bottom, and let me point out some important parts. Switch is a reserved word, and you switch on the value of a variable. You have an open and close curly brace, that is the beginning and end of the switch statement. Case is a reserved word, and so is default. The syntax for this is very different. Instead of having many if-else statements, it's a more organized way of making code where you have a lot of decisions. This will be some kind of numeric value or character value. All of these, value 1, value 2, value 3, 4, 5, up to value n. You have no curly braces here, but you have the body of the loop basically all occurring here. It can only have one statement, or it can have multiple statements. What kicks it out, what tells the body of the loop is done, is this break statement. When it hits a break statement, it goes down to the bottom and the next line of code. If the value of this expression is value 1, this occurs, goes down. If it's not value 1, it goes like a waterfall to value 2. These occur, then the break kicks it down. If it is this particular value, these statements occur, break kicks it down. The default is if none of these values are the value of this variable, it's good to have defaults at the very end, and those occur. And then this could have a break, but it doesn't really need one because it's at the very end, and then it would go down here. Anyway, here's a nice diagram of this. So you're looking at the value of the variable. Is it this? All right, do these bunch of statements, break, kick down. Or is it this? Okay, etc. You can have as many as you want, as many different statements as you want, and it breaks. Here's a default, and then goes down. So let's look at this. Here's some real code for this. Let's say that the value of day was 4. We're going to switch on day is the correct way to say that. And what we're doing is we're asking the value of this. This flows like a waterfall. I purposely put them out of order because it doesn't go at the lowest or the highest first. It goes to the top value you are checking first. Is the value of day 3? No, it's not. This does not occur. Is the value of day 1? No, it's not. This does not occur. It's not 2. This does not occur. It is 4. So system.out.println, Thursday prints out. This break kicks it down to the very bottom, and the output would be Thursday. But let's look at this, a little bit more efficient use of a switch statement. We have a complicated if statement, and then inside the if statement, we have a switch statement. Let's pretend that you are a word processing system, and your task is to count all of the vowels and all of the consonants in your history paper. You don't want to count commas. You don't want to count exclamation points. You don't want to count blank spaces or line wraps. All you want to do is count letters. So we are pretending also that you have already gone through your document and everything is lowercase. You are also pretending that there is something called vowel and something called consonant that you have already assigned to be an integer, and they are starting with a value of 0 because you're going to count how many there are. And here's what happens. If A is less than or equal to letter and letter is less than or equal to Z, what that means is if it's a letter in between and including A and Z, and of course we are checking their ASCII value, you switch on letter. Is it an A, E, I, O, or U? You're going to increment your vowel count. Now this is very different from the switch statement that I just talked about, so let's look at this. You have no statement here, no break statements, no statement of what to do. It's all right here. So here's the thing. If it's an A or E or I, O or U, you want the same thing to happen. So if you don't put a break statement, the waterfall keeps on flowing. You want the exact same thing to happen no matter what vowel it is. You want to increment the vowel count, and then you want to kick out and go. Well, if it's a letter between A and Z inclusive, and it's not any of these 5, then it must be a consonant. So this is a great way to show the use of defaults. Increment your consonant count and then break. And of course, we're assuming that we would do this in some type of loop. We're going to learn about looping, doing things over and over, and we're going to grab every character in the whole history paper and look at it individually. All right, that's all I have for you today. That was a long one. Hope you hung in there. Thanks.